In the previous example, we saw how a common table expression could be used to structure a query and sometimes simplify it. But there's some additional stuff that you can do with common table expressions that are really hard to do any other way. And one thing that common table expressions let you do is something called a recursive common table expression. So when you create a common table expression, you're creating a select statement that's returning table data, and you're naming it as your common table name. But the select clause can actually refer to the table that's being created. So kind of like Inception, a dream within a dream within a dream. So the results that I'm returning here can actually include additional results fetched from here, which can include additional results fetched from here, and so on and so on, until some termination condition is reached, like you run out of data that matches. Now, this comes up in some fairly specific kinds of contexts, usually when you're dealing with data that's structured in tree form. And the book gives an example of when you want to know reporting relationships. A manager can have several people that report to them, and then some of those people can be managers as well that have other people reporting to them, and so on down the line. And so you get this tree of reporting structure where people report to people who report to people to report to people. And another example of similar kind of data is like categories on eBay. So I actually have an incognito window parked at eBay right now. And if I go to the root category at eBay, and let's go collectibles and art, and what I want to do. Let's look under entertainment memorabilia, movie memorabilia, film glass slides. And now I'm at a leaf category. And so you see I get this little trail of breadcrumbs where film glass slides is a subcategory of movie memorabilia, which is a subcategory of entertainment memorabilia, which is an eBay category. And there's some of these, the depth on some of these maybe 5, 6, 7 deep. Some of them only a couple, 3 deep, and so on. You can sort of add subcategories to subcategories. And imagine you were trying to write a join that would list all of the subcategories under a particular category. So, for example, all the subcategories under entertainment and memorabilia. Well, I can take the table that has this and then join the table that has that, and then join the table that has that. But what if it's 4 deep? I need another join to get that table. And if it's 5 deep, I need another join to get that table, and 6 deep, and so on. There's really no fixed number of tables that you need to join with to get all the way to the bottom. On the other hand, the way I'm going to define the subcategories of a category is get all of the subcategories of this category, and then get all of the subcategories of those categories. So to get all the subcategories of this category, I get all the subcategories of this category, and then get all the subcategories of those categories. And same thing, same thing, same thing. So there's just the basis, which is the starting category, and then the recursion step, which is all the subcategories of that category. Now, this is sort of an advanced concept and takes some wrapping your head around, so I'm not going to expect you to actually write a recursive query, but I want to show you how it works, and at least you should understand the big ideas of how this is fitting together. Let's take the other direction first because it's a little easier. So if I want to know the trail of breadcrumbs that gets me from eBay to film glass slides, the way I define that is I start with film and glass slides, and then I get the parent category, and I look for the trail of breadcrumbs for the parent category. And to get the trail of breadcrumbs for movie memorabilia, I start with the parent category and get the trail of breadcrumbs for the parent category. So that gets me entertainment memorabilia. To get entertainment memorabilia, I get the parent category and look for the trail of breadcrumbs for the parent category. Then for eBay, I'm at the root, and so I'm done. So a basis step and a recursion step. Now, to demonstrate this, I've set up a eBay database, and it's really simple. It just has two tables. There's categories, which has an ID for each category, and then a name. And names are not unique. I can have multiple categories that have the same name. And then there's the subcategories, which has the ID of a child category and the ID of a parent category. So for example, this might be movie posters and this might be memorabilia, and that says that movie posters is a child of memorabilia. So let's go ahead and switch over to eBay, use eBay. And then I'm just going to write a simple select statement that links these tables together and displays some content. So select top 50 star from, and then I'll start with subcategories. And subcategories has a child ID and a parent ID. So I'm going to join categories as child on subcategories.child equals categories child.id. So that's going to give me the name of this child category. And then I'm also going to join with categories as parent on subcategories.parent equals parent.id. So this should give me the first 50 child-parent relationships along with the names. And so I see that antiques is a child of eBay, art is a child of eBay, baby is a child of eBay, and so on. So these are all direct children of eBay. And then here I get some children of antiques. So antiques is a child of eBay, and then Asian antiques, and let's see, antiquities, architectural and garden, Asian antiques, and so on. These are all children of antiques. And then if I scroll down a little further, actually that's enough for the first 50. So let's go and write a common table expression using this. So with cats as, and there's my select statement. And then I'm going to select top 50 star from cats. And then for the actual query, I'm just going to duplicate this thing here. And then tab this over. And I don't need that top 50 anymore. And you can tell I'm going to get an error. And it says the column ID was specified multiple times for cat. So there's one additional restriction. So here, if I execute this query, you'll notice that I have two columns named ID, two columns named name. And that's perfectly fine for a select statement that you just run from top level. But when you use a query as a common table expression, each column in this table has to have its own ID. I'm sorry, its own column name. And that's just a restriction on common table expression. So if I want to return all of these columns, I have to give them distinct names. So let's go ahead and return. So child and ID, these are the same values. So I'm going to return child. And then I want the child's name, which is going to be child.name as child name. And then I want parent and parent.name as parent name. Okay, so now I should be able to execute this. Great. So that works. Now, so far this is just a regular common table expression, but once again, I want to find the trail of breadcrumbs. So I'm going to add a recursive common table expression here, which finds the children as, bear with me, the logic here is complicated. But I start with my basis step. So if I'm looking at eBay over here, my basis step is I'm starting here at this child. And then my recursion step is I want to know the parent and the breadcrumbs for this guy. So this is going to be select star from cats where child name is equal to, and then I will use this category. So copy film glass slides. Where child is that? So this is not recursive yet, but let's make sure that this actually matches something, because eBay categories get updated periodically, and so they don't all actually match. But this one appears to. Actually, let's go select top 50 from children. And this should return one row. No, it doesn't. So let's go. Let me just pick a different category that actually does match. Let me try film cells. Okay, good. So film cells matches. So this is my basis step, and it gives me the film cells. The parent is movie memorabilia. Then for the recursion step, I want to find the categories where this is the child, and I get some parents coming back. So those are going to be the parents. So I use union all here to add additional rows to the children table. And those rows are going to come from cats join children on, and then cats is going to be the parent categories and children is the children categories. So what I want to look for is the ones where cats dot child is equal to children dot parent. And incorrect syntax near from. Oh, I need my select here. So what do I want to come back? I want to get for this new parent category, cats. I want cats dot child, and then cats dot child name, and this actually works. And then I want cats dot parent and cats dot parent name. Actually, okay, so that's going to give me a row that has movie memorabilia as the child and child name, and then whatever the parent of movie memorabilia as is as the parent with parent name. And that's going to add that to children. And then it's going to repeat this process. So then it's going to look for the parents of the parents and the parents of the parents and the parents and so on, all the way until it gets to eBay. And then nothing is going to match with eBay as the child because eBay doesn't have any parents. So complicated, but let's go ahead and see what we get. So we see that film cells is a child of movie memorabilia. Movie memorabilia is a child of entertainment memorabilia. Entertainment memorabilia is a child of eBay. Now we can do the same thing in the opposite direction. So for example, this gives me the trail of breadcrumbs from film cells up to eBay, but I can go in the other direction and I can ask, for example, what are all the children of entertainment memorabilia? So let's start with this. And we're basically going to go in the opposite direction. So cats is the same. Children now, we're going to start with, let's say, movie memorabilia, because I don't want too many coming back for just yet. So memorabilia. And then instead of starting from children and working up to parents, instead of adding to children as we go up, we're going to add to parents and go down. So this time we're going to go parents, 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 parents. So here are the set of parents, and then the new cat that we're adding is going to be the child of one of these parents. So the child cats dot parent is going to be the parents cat dot child. And yes, this is hard to understand, but it should work. Sometimes you just have to hit the execute button and hope for the best. So what do we get? And I also have to change my basis step. I actually want parent name equal film cells, because I got an extra level in there. Oh, did I fix, am I on the right one here? No. Yeah, I just edited the wrong query, so let me undo that. And then let me fix the right query, which is this thing right here. And this should be parent name is movie memorabilia. Okay, let me squish that down again. So I'm going to execute this query. So this should be all the children of movie memorabilia, ads, flyers, canvas prints, clipping, film cells, and so on. And then some of those children have children as well. So for example, wardrobe is a child of movie memorabilia, and originals is a child of wardrobe. And then scripts has originals and reproductions. And then signed is a child of originals, which is a child of whatever. And then props has original and reproduction. Then press kits, there's various subcategories from there. Press books, posters, and reproductions pre-1940. So it actually goes fairly deep. If I go up to this query here and I look for all the breadcrumbs for categories named pre-1940, and I should have multiple categories possibly. Let's see all the breadcrumbs that we get there. Okay, so 1940 goes to brochures, calendars, telephones, ad flyers, and yeah, so actually figuring out that trail of breadcrumbs from this display is kind of tricky. So let's actually display it like it looks on eBay as parent, angle, child, angle, and so on. We can actually do that here with a couple of fairly simple changes. So all I have to do is change what's coming back in my children table. So I want to have CID, actually child ID, which is child, and we'll do child name. And actually, I'm not going to do child name. I'm going to do parent. And then here what I'm going to return is parent name plus, and then I'm going to put in an angle bracket plus child name as name. So I'm concatenating the parent name with the child name with an angle bracket between them, and that's going to be the name of the child. And then in my recursion step here, I'm going to return child, parent, And here, it's going to be parent name plus angle bracket plus cats dot child name. So this is getting glued into this third thing, and this is, and actually instead of this, what I want is children dot name. Right. So it's going to accumulate parents and breadcrumbs. This is actually the breadcrumbs. And then to get the next breadcrumb, I add the parent name to the previous breadcrumb. So once again, tricky to understand, but should work. Let me execute. Okay, so I have pre-1940 as a child of brochures. And then if I keep going, so pre-1940 is a child of Vaseline, which is a child of glassware. And then when I get all the way to the top, eBay, that's where the trail of breadcrumbs actually ends. And so if I just want the full trails, I can add a condition here where parent equals 1. So this is going to be all the trails of breadcrumbs that include pre-1940. And I see there's one in pottery and glassware, Vaseline, entertainment memorabilia, theater memorabilia, souvenir programs, playbills, television memorabilia, photographs, movie memorabilia, press kits, press books. This is where I was before, so here's the full path down to there. And then same kinds of deals, lots of movie memorabilia with pre-1940 stuff in it. Then there's collectible radio, phonograph, TV, phone, telephones, pre-1940 telephones, calendars and brochures under paper collectibles. You see different lengths in these paths, different lengths in the trails of breadcrumbs, but it seems to work. Now I can do the same thing just to close this out. I can produce trails of breadcrumbs for all these child categories the same way. And this is going to look pretty much exactly the same. So I'm just going to return child, parent, and then parent name plus angle plus child name. So that's my basis step. And then for my recursion step, I'm going to return child, parent, and parent name. Okay, this time it should be parents dot parent name plus angle, and let me call this as name here. And then this is just parents dot name. And then this is cats dot child name. Okay, so I'm building the parents from the root on down, and then I add the child to get the next breadcrumb. And I left out cats dot parent. Okay, so let's go ahead and execute that. And this should be all of the subcategories under movie memorabilia. And so there's the immediate children. And here are some children of children. And children of children of children. And lots of press kits. And there we go.